Hi, I've just bought a Metcal MX-5251 to replace or complement my current soldering irons, and I thought I'd do a quick video of the unboxing and maybe some first impressions of it. Right, so I think we've got everything in shot, so I'll start opening this thing. So we've got the MX-51AV, I think that's the stand. The MX-H1AV, which is the advanced handpiece. The MX-UK5, which is the desolder gun. Mains lead. And the unit itself. Okay, so we'll open this box. It's got an information leaflet, bit of foam padding, and the unit itself. So I purchased this unit from the solder connection. They've put a wanky sticker on here, so that's coming straight off. Let's get something to protect the paintwork. It didn't take much effort to get rid of. So the unit itself is pretty chunky. It's quite heavy as well. I don't know what the weight is on this thing. It's a completely metal construction. There's the LCD on the front and the outputs to the soldering irons, so you can run on this one 2 irons simultaneously sharing the 80-watt supply, or you can switch between them and then they get the full power. So I'll shift that to one side. And in here we should have the handpiece. Handpiece, the removal pad, so that you can take out the soldering iron tips while they're still hot. So you just insert them in and you can pull them out if you want to swap the tips over. The cables are weird. Must be a silicone. It's not quite the same as the material that they used on their previous products, like a matte silicone. This one's quite shiny. It's very lightweight. It looks like it comes with an alternate grip, probably green to signify it's been used for lead-free. think this is the stand for the handpiece. Comes with a little quick start guide. Don't think it says anything particularly useful. It's got the standard sponge. I don't really end up using these very often, but I normally just use the sponge to wipe off solder. And I think this has an adjustment for the angle that you want it at. Now ordinarily, I think if you buy the normal MX-5200, that's all you'd get. You get the handpiece and the power supply. But I thought I would go ahead and buy the desoldering tool for desoldering through-hole parts. This is quite expensive on its own. I think this pack with all the desoldering stuff, probably about £300 or £350. I think this lot together came to about £800. I don't know what that is in US dollars. So in here we have another stand. So we have a sponge. Nowhere to put it, I can see. And then we have a bag of bits and bobs. So we've got some cleaning tools, because it doesn't come with any tips. You have to buy these separately. But the tips themselves, on the desoldering tool, actually you can't see it because they cover it with solder from the factory, but there's a hole in the middle, which is what you put over the through-hole part that you're trying to desolder, and you get suction through this Venturi port here, and obviously every so often that might get gunked up with solder, so you can clean it out with the cleaning brush. I'm not quite sure what the tip cleaner is. I'll have to have a look at that. And then it looks like there's some spare filters, because in the handpiece, when it sucks the solder through, it gets trapped in a filter. And so this should be the handpiece itself for the MX-DS1. And that's actually pretty substantial. It's quite heavy actually. Significantly better. I mean, I've used some of these Chinese desoldering tools, and this is solid as. Yeah, it's quite impressive actually. And finally, we have the bag, which has. So this has the compressed air line and also the electrical connection to the heating element itself. So these ends, I think this ends up screwing in here, and the compressed air line supply here. And the way it works is you plug this end of the compressed air line into a separate compressor. So you do need a compressor or an air supply if you're using it in a factory environment or something like that. I think it needs 80 psi. I don't know if it says in here. Okay. Not sure where it says, I read it somewhere, I think it's 80 psi. So it applies compressed air, and you saw on the heating element there was a little suction port, and when you apply the compressed air to the desolder gun, it draws air in through the heating element using the venturi that's in the handpiece. I don't think you can see it actually, but yeah, it just draws air through here. You do get some air discharge from the gun itself, but it has to escape somewhere. And that looks like it sits nicely in the stand. And obviously the air supply and the cable to the power supply aren't on the bottom, so it doesn't get obstructed by anything. So I'll just tidy all this lot up. This is the MX-5251. So this is the power supply that you get in all of the MX-5251 packages. So if you just buy the MX-5210, which is the advanced handpiece and the power supply, that's the same one you'll get. And if you buy it with the desoldering gun, or both the, whichever configuration you decide to get, this is the same unit that you get across the range. On the front there's an LCD with a button to switch between the two outputs or to enable both outputs simultaneously. So the power output is 80 watts in total, and normally you'd have up to 80 watts available to your soldering iron or desolder gun or whatever, but you can also plug in two items at the same time, and it will share the 80 watts between the two outputs. On the back, so there's just an IEC connector, and I think I've seen a few that have a port which is maybe for a firmware upgrade or something. There may be something behind this panel. Might have to have a look. But it's a universal mains input, so 100 volts to 240 volts AC, 50 to 60 hertz, and up to 125 watts drawn from the mains. On the top, it looks like there's just the power switch. I don't know whether this switches before the transformer or afterwards. I know on the MX-500 the transformer's on all the time. It seems to switch the secondary side, presumably to try and reduce the number of times that you have inrush current being drawn from the mains, especially if it's in a production environment where there might be tons of them in a row or whatever. The output from this is running at 13.56 megahertz. I have a PS900 which has an output at 450 kilohertz. I'm not sure in practice what difference the output frequency has, but the RF heating technology is significantly quicker than almost every other soldering iron that I've used. So I mean, at the moment I've bought this soldering iron to replace the PS900, and then I've got a couple of Antec soldering irons as well, which just have standard resistive heating elements with analog feedback loop to maintain the temperature. And these, I mean, there's nothing actually too wrong with these. The 690 is quite good. I bought this set of tips for SMD Rework, and they're pretty good. I'll probably continue to use that soldering iron and those tips, because they're quite expensive to buy individually for the MX-5251 series. But once you use one of these soldering stations, using anything else is a bit of a step back. Some of the new Pace and also the Ursa soldering irons are pretty good, but I find that you can manage to dump a lot more heat into whatever you're trying to solder with the Metcal irons than any of the others. So I'll just grab a mains lead and we'll power this thing up and see what it does. Okay, so it's now plugged into the mains. So if we turn it on, it says the version number 1.33, and then it just says open error. That's because there's no irons plugged into either of the outputs. Pressing the button, you saw the animated square says which output is active, but obviously with nothing plugged in, it's not going to do anything. I did see on the spec sheet that it says it's got AC ground circuitry to make sure that you've plugged it into an earthed outlet, so presumably it won't let you use it on a floating supply, so we might have to just quickly test that and see what happens if we plug it into a floating supply. I'll just go and grab my isolation transformer and we'll plug it in. Right, so I've got my isolating transformer, mains in, and then I've got an IEC lead which goes from here into the back of the iron. So this is the configuration that we have here. This is the isolation transformer which I've just put on the table here. This is our mains wiring. This is the point where the main supply enters the house, and this is the distribution network with the distribution transformer here, which is at the local substation. So the transformer is formed from 3 separate windings with a central star point, and this is where the neutral comes from. The supply to my house is a single phase supply, so the live is tapped from one of these 3 phases, and also at the star point it's tied firmly to ground, so at the transformer there will be an arrangement of metallic structures or whatever under the ground, forming a low impedance connection to the earth around the transformer. At the point where the main supply enters the house, the earth supply can be formed in one of 3 ways in the UK. So the first way is the earth supply comes separately from the live and neutral, and is supplied as 3 conductors into your house, and that's your earth supply there. More commonly in new developments, the earth supply is tapped from the neutral at the point where it enters the house, so you just have 2 conductors in the cable that connects to your house, and then the neutral is tapped to provide an earth supply that goes around the house, and then obviously you have a very low impedance between neutral and earth, which means that any fault currents from phase to earth also have the opportunity to trip any protective devices in the house. The third way is through an earth stake, and this is obviously the highest impedance here because it uses the earth to form a path all the way back to the transformer. So here you can see this is our mains cord from just direct from a main socket. And if I put that in the earth terminal and touch this on the transformer casing, we have a low impedance. So this is, you can see this is connected here, but if I connect this into one of the, this should be the neutral, we just have a very high impedance, showing that there's no connection to the earth terminal. So I don't know what happens here. It says it has some kind of protection against an unearthed main supply, so the transformer's now on. And if we turn this on, it still powers up. Oh, but it says ground fault. But it looks like it's still running. Oh no, it doesn't operate at all. Okay, so if you only have if you have an unearthed supply in your house, it doesn't look like you'll be able to use one of these soldering irons. Right, so we have our F connector. It's a slightly odd connector. It looks like you tighten this outside ring, which causes the outside of this to connect firmly against the connector on here. So if we just plug this in, give it a twist. That's alright, that's in firmly. And if we turn it on, I need to turn it on at the plug, sorry. It's starting up. Yeah, it says ready. Just sitting there idle. So while the iron is in the stand, I think there's a magnet in here which affects the properties of the cartridge that's in here, and it just means that it goes into a low power state to try and conserve the life of the soldering iron tip. So let me just grab some solder. So I think so this looks like a bar graph at the bottom here, so when I remove this from the stand it should heat the soldering iron up to full operating temperature, and then we should be ready to go. So let's see what this is like. So it's just jumped up there to about 80, and now it's hot. There's smoke coming off the end. Let's give it a tin before it gets an oxidation. Yeah, and that's it, we're off. I don't know how far the tip cools down, but I mean it's hot straight away really as soon as you remove it from the stand. I don't know if the infrared thermometer will be able to pick up the temperature, because unlike a lot of the other soldering stations, the temperature on this is set by the soldering cartridge. So you can buy a couple of different cartridges with the same tip, but they have a different temperature. So you can buy a different one from the range if you need a bit more heat into what you're soldering. But generally, I mean, I've been using Metcal soldering irons for quite a long time at work, and you know, I've never needed to change the temperature. I haven't really ever had to twiddle the temperature on the Antec soldering iron either. If anything, it's the hotter it is, the better. But the downside to the plain soldering irons is that the iron's hot the whole time that it's plugged in, so the tip does start to degrade quite quickly if it's at full temperature all the time. So I've got my Fluke 62, which came free with the multimeter when I bought it. I don't know if we'll be able to read a temperature here. I mean, it's picking up about 45 degrees centigrade at the most. I don't know what it's like. So that should be hot now. If I put this right in front. No, this is useless really for taking the temperature. Just grab. So I'll just grab my meter. Right, I'll just turn this on. Can you see the display is visible. Menu, temperature. There we go. So if I place this on the tip now, it's going up. Yeah, it's about 170 degrees probably while it's in the stand. This is hot now, so if I just touch this on here. Obviously the thermocouple's got to warm up as well. I'm probably not making the greatest contact here. Add a blob of solder onto the tip of the soldering iron here. And now we're going. So it seems to be settling around 370 degrees while it's out of the stand. It's a bit warmer than I expected, but yeah, I've never had any troubles with using one of these irons in the past, so that's good. So I'll just grab a PCB and we'll just try and solder a few things with it. Right, so we'll have a go at soldering a few parts onto this board. This is a USB DAC that I've been working on for a couple of weeks. I just had the boards made and they've just come in this week. It's based on a Texas Instruments PCM 2704 or 2705, and the main idea behind this was to create a board that would fit on top of a Raspberry Pi. So there's mounting holes here and here are the same as the ones on the Raspberry Pi. You can just bolt it on top, plug in the USB port, and you get your line out through a couple of phono sockets or just a 3-pin header, so that it can be used as a wireless streaming music player. So I bought a couple of Raspberry Pis. I'm going to have a play at putting some of the software on there, probably a derivative of the Squeezebox software, because I already have a Squeezebox server running in the house. And then yeah, there'll be a Raspberry Pi, one of these bolted on top with one of the USB Wi-Fi modules plugged into the USB port. Obviously this plugged into the other one, and then depending on where I use it, I'll either use the line out, or there's also on the top part of this board there's a headphone amplifier which can drive 600 ohm headphones at quite a high volume. This is based on the LME 49600 current buffers, and another design which I need to work on is a board that plugs on top with a Class D amplifier, so it can just run a ceiling speaker or something like that. But anyway, let's have a go at trying to solder a part onto the board. This might be a bit tricky. I'll probably soon find out why no one manages to solder very well in front of a camera, because this is right in the way. I don't know if I'll be able to get to this, but put a bit of flux on the pads. I quite like this. This is made by Circuit Works. It's just a flux dispensing pen, and you can actually refill these pens. So I've got a little pot of liquid flux, and you can inject some more flux into it when it runs out. The tip on these doesn't really ever seem to wear down or anything, so you may as well reuse it. And the way that I normally solder these parts is, oops, I add a bit of solder to one of the pads. I mean that's wetting that pad straight away. It's pretty damn quick. And then put the part in place, but the camera's right in the way, so this might be a bit more tricky. I apologise if it causes any shadows on the video. Right, I think we're in place there. Just melt the solder a bit. There we go. That one's on, and just move the camera strap out of the way slightly. And we'll just do this one, and we're done. Yep. not bad. Let's try one of these capacitors. Just grab it. So a similar method. Put some flux on each of the pads. Apply a bit of solder to one of them. I'll just place it with my fingers because it's a bit easier than trying to get the tweezers in there. If you can probably just about see that. Just reflow the solder here, that's that side done. And this side is a ground plane which covers quite a large area of the board, although it is at the edge of the board, but yeah, it just takes slightly longer, but that's that side done. Yeah, I mean that's pretty good. The soldering iron's a nice weight. Yeah, it's alright. So I was just having another look at this this stand. It looks like you just have to undo these two screws, and then you can, and then it forms space for the sponge. So we'll just have a quick go at that. I don't really know whether we'll need to use the sponge or not when using the desoldering gun, but I may as well have a look anyway. Yeah, so that just comes off. That's about right. Oh, so there are threaded inserts. It didn't feel like it when taking these out, but there are threaded inserts for these screws. And you can just move this. Oops. And yeah, now there's space for the sponge in the front there, and presumably well, actually the gun does. I guess it rests on the front here. It's not actually interfering with it, so yeah, that's fine. I don't know whether I use the sponge or not. I might put it back to how it was, but yeah, okay, that's quite good. Right, so I'll probably do another video demonstrating the desolder gun because I'm just waiting for the air compressor to arrive. I do have one, but it's really noisy and not really any good for use in the house, so I've ordered, I think it's a Clark 3/9 compressor, which is an ultra quiet compressor. It's quite small, only 9 litre air capacity, but that should be fine. And that's much more suitable for use in the house. I think it's barely audible actually. We've got one at work, and you know you can hardly hear it when it's in use. But overall, I mean, the system seems quite good. These 3 parts together, I think it was £740 plus VAT, so quite expensive, I suppose, for a hobbyist. Without the desolder gun, you can buy the MX-5210, I think, for about £440 plus VAT. So this is actually quite a substantial part of the cost. But I mean, it's built pretty well, and I would expect it to last quite a fair while. I mean, the Antex soldering iron in the background, the yellow one, is probably getting on for 20-25 years now. The black Antex one is 10 years old and it still works, you know, perfectly. So I wouldn't expect this one to go wrong in the near future. So actually, spread over the years, it's not too bad. Yeah, thanks for watching, and hopefully I'll get some more videos up soon.